In this video we will show long-shot diffraction effect on thin wire. These left and right pictures show the common setup and result of this experiment, respectively. The central bright spot is approximately twice as wide as the others, similar to a single slit interference pattern. At the center of the fringe pattern, the unobstructed light beam can be seen as an extra bright spot. In this experiment, a lead wire of a quarter-watt resistor is used as the diffracting object. Its diameter is 0.6 mm. The distance between the wire and the wall is around 20 meters. This time, the central bright spot looks narrower than common depiction of thin wire diffraction result. In other words, compared to the usual central bright spot, it seems to be divided into three parts. Let's remove the wire from the light path to see the pattern of unobstructed beam. We get a circular bright spot with an additional tail to the left due to imperfection of the laser pointer. You can also see some diagonal lines caused by the imperfection of the camera, which was evidently shown when it captured the lightings. Now the experiment is repeated with shorter distance. The brightness of the laser beam makes it hard to see the central bright spot clearly in real life, but the camera seems to capture the details at some angles. Let's repeat the experiment from further distance. The central bright spot can be seen to have some additional dark spots, which are the result of destructive interference between original light beam and diffracted light beam. Now we will use a piece of palm fiber from a broom as the diffracting object. The central bright spot seems to be divided into smaller parts, just like the result with a resistor lead. Now the laser pointer has been flipped, so the imperfection of the original light beam is located at the other side. The pattern of the central bright spot is also flipped. The next experiment will use two steel stripes as a single slit aperture. Let's compare previous result with single slit diffraction from the same distance. This time the central bright spot looks like a continuous band. Finally, we used two pieces of paper to make the single slit aperture. We still get a continuous band at the central bright spot.